Okay, thank you. So my presentation is about the assessment of these recent multi-temporal biomass change maps. So it's an ongoing work, and it consists, and the research team consists of my PhD team and many collaborators, mostly data providers, come from the map maker side and the data and the reference data side, and other collaborators. So I would start by giving you like a brief overview regarding the assessment of biomass change in single epochs for these global biomass maps. So of course, you're aware that there's been a lot of maps produced globally, biomass maps in the past decade, like 15, 20 of them. And as a standard operating procedure, they should be independently validated. Also in the context of the COS protocol, and also of course in the context of the broad user groups that of these biomass maps. Um, and in line with that, we try to have this framework to do these assessments, to do these comparisons of map biomass and reference data biomass at ideally at aggregated scales. And that has been implemented using a tool, this platform map tool, which is also currently being implemented in the map platform. So if you want to assess the map using maybe open data or even private data, this is the tool to use. One of the options to use the tool for that purpose. And also one of the functions of that is that yeah, there's an option to reduce these, to model the bias, the systematic difference, and partially reduce these biases for these global maps. As you can see here in the graph, where in the blue, one is the assessment using these bias-adjusted map versions. Yeah, but still there's this bias doesn't disappear. So there's still this underestimation of high biomass, mainly because we lack data for these very dense forests, high biomass forests. So diving into biomass change, so of course you're aware that in the past 1-2 years, there's been a lot of multi-date biomass maps produced. So it's really interesting, but also quite challenging in the context of map assessment. So I would quickly tell about the approaches being used, state of the art being used for these multi-date biomass maps. So mostly if it's multi-date like periodic maps, annual biomass maps, it's mostly ALOS-based, these high resolution biomass maps. So if it's like a time series biomass map, so it's mostly produced using these time series satellites also data, like Moody's, Elwood, and these legacy data sets that Nuno has showed us. And of course, you can also produce like a biomass flux, carbon flux using a baseline biomass and like a Hansen loss and gain data and some other activity data to put integrated. So here's the current list of these multi-data biomass maps, and we're particularly looking at these specific ones, the CCI map, the WRI flux model, the one that Nancy produced, the JPL map from the team of Sasan, and also the new Elwood map that Hui showed us a while ago. And of course, these maps come from they're all global, but they come from different resolutions, also different epochs. So that's something to consider also. And we have these derived into these objectives. That first, of course, we need some dependable and reliable reference data. So this is the first step for this study to well, compile these reference data and assess, of course, their suitability, their quality. So this is this part. So we also try to estimate their uncertainties at the reference data level if it's unavailable. And of course, as I said, it comes from different resolution, and in the context of map users, they also have quite some requirements regarding spatial resolution. So we try to do the assessments at different levels, aggregation levels. And of course, we try to assess how these maps compare to each other, whether they agree or disagree on loss, gain, or no change pixel. So yeah. So of course, we're particular in the past decade net biomass change, which is 2019. And with all these pre-processing and quality filters and the next big step would be to make the maps and the reference data more comparable. So it's quite straightforward for some other maps, while some other maps needed some extra modification. For example, the flux model, we needed to excuse, change all the variables related to the 2000 baseline into a 2010 baseline. And we needed to just derive the above ground component only, and yeah. So we also tried to get rid of some interannual variability of sometimes series products. So we tried to average some periods in some windows, like a 3-year window. And yeah, for in terms of the plots, the reference data, we relied on some remeasured NFIs. We removed very old plots, and of course, we tried to filter out those deforested that has been deforested after the second measurement and before the map epoch, the second map epoch. So they will not see. So, for example, the plots can still the maps can detect losses while the plots is otherwise. So that should be accounted. And we also relied on these multi-date open source LiDAR maps, high resolution, and also not just open source, but also some data providers under data use agreements provided something for that. And we tried to look also into this FRA data, only filtering out those high quality countries with good reporting capacity, mostly those countries with double NFIs. Yeah, and of course we try to aggregate also, and that's quite straightforward for the maps, but for the reference data, we try to account for the uncertainty and use that as the inverse of the uncertainty as weights in order to have a weighted average at aggregated levels. So in terms of the reference data, yes, so this is what we have right now. It's mostly European NFIs and some NFIs in the topics, and and some LiDAR maps. See in the green part, it's of course US, Brazil, and some in Europe. And excuse me. And in terms of the FRA data, yeah, we use mostly European temperate data in that case. So it's obviously spatially clustered. So this is the first batch of the data that we had. So there's some more expected, and the communication with potential data providers are ongoing. So yeah, this is expected to increase also. Okay, so in terms of the comparisons of the LiDAR, the NFI, and the FRA data, biomass change in the past decade, grams per hectare. We try to compare all the maps, and we see some sort of agreement with the LiDAR data, mainly because they're both spatially explicit. But that agreement has disappeared when we use NFI as reference data, and there's some variation among the maps in terms of the results of the FRA. This doesn't mean that the maps are doing a bad job in this case. In the NFI case, it's also related to the number of NFI samples inside those coarse grid cells. So it could be most likely they are insufficient to represent the grid cell. So it happens also. Okay, so in terms of the different assessments at the different aggregated scales, from bottom to top, we see we go from fine to scale assessments. So this is using this is the mean difference, or the bias, and this is the RMSD. So of course, it's quite known that of course scatter decreases with aggregation, but the bias persists, as you can see here in the strong colors all throughout from bottom to top. So that's quite a problem also, as mentioned in the previous presentations, and that originates, for instance, if it's an underestimation of biomass loss, it originates from the baseline epoch, which is 2010, which is has this underestimation of high biomass. So if if forest loss happens, that loss likely is underestimated as well. It's quite interesting figure also. We try to map the changes on the top right figure with the, of course, red is loss and green is a gain. So for the four maps, and we try to overlap each of one. We try to overlap them into this figure. So if you see a redder pixel, it means that they all agree on biomass loss. And if you see a greener pixel, it means that most maps agree on biomass gains. And if it's like grayish, it's like most of them agree on no change on at a certain thresholds. And if it's white, it means that they quite disagree with each other, which are quite common in some regions like the Amazon and some also some regions. But interestingly, there's some agreement also, some agreement level, especially in terms of biomass loss, and also some agreement on the like green spots like these greener regions. Yeah. Some concluding remarks. Yeah, so yeah, there's been quite a lot of work in terms of assessing biomass, but single epoch biomass, and this one is like one of the first steps to explore which reference data we have and how maps compare with these reference data in terms of course, biomass change. The 25-kilometer assessment shows us that LiDAR agrees. There's certain agreement with the maps and some LiDAR maps, some local airborne LiDAR maps. And of course, the aggregation effect. There's some scatter decrease, but of course, these bias persist. And there's some level of agreement among maps in terms of loss and gain hotspots. Yeah. So moving forward, this is like the first bullet concerns like the, the maps are increasing. So, but what about the reference data? So yeah, so I think this will be complemented by the ongoing and efforts like the super sites and geotrees efforts also. But of course, the uncertainties of both maps and reference data should be accounted when we compare them. It's also an option to combine the biomass map estimates because especially we see some variation in some results. And also we try to cater these certain user needs, and yeah, we try to provide this spatially explicit map for them for these users. And also, yeah, it could be interesting to for a broad range of users to use these kinds of map products also. So these are just examples. So I think that's it from my side. And